Okay guys, today what we're going to do is we are going to start with our first official SOL warm-up day. And Miss Logan should have given you a packet. It's like a little mini packet, and it's going to, it's about, I don't know, 6 pages long. Okay, and we're going to cover a few of these topics this week. And then next week you guys will have a short little mini quiz on all of these topics, and then what we'll do is we'll cover a couple topics and you guys will have a quick mini quiz. It's a good way to decide whether or not you know what you're doing, and also to get some grades. Okay, so something I want you guys to notice is at the top left hand corner of this page in your packet, you see that it says 7.1a, and then it says negative powers of 10. Okay, remember this section is called 7.1a, so your homework for this is going to also say 7.1a. You'll see it in your packet. You guys are going to do 3 different topics today. We'll do 7.1a, b, and c, which means you're going to be doing the homework for 7.1a, b, and c. Okay, so let's go ahead and start, let's start with the powers of 10. Okay, this is, again, all of this is going to be a review. All right, and notice in our chart we have positive powers of 10, we have 0 as a power of 10, and then we have our negative powers of 10. All right, so let's start with our positive powers of 10, and this is when we expanded them and we turned them into regular numbers or fractions. So let's start with positive 10 to the third power. So the first thing they do is they have 10 to the third, which we know as an exponent fraction. Like this column is a little bit repetitive, I think, because all of these are just going to be kind of over 1. All right, so expanded, we have, since it's 10 to the third, that means we have 3 10s. So we have 10 times 10 times 10, okay, over 1. Okay, multiple fractions means 10 over 1 times 10 over 1 times 10 over 1. Okay, which means 10 times 10 times 10 is 1,000, all right, over 1. Written as a regular number or a decimal number, it's just 1,000. Okay, and in words we say 1,000. All right. Okay. And then over here we have 10 squared, and notice, guys, a couple of things. Notice that the exponent right here, 10 to the third power, always means how many zeros. Okay, when your power is positive, you should have a big number. So that means you're going to count 3 zeros, 1, 2, 3. And that's how you know what you're going to, what the number is going to be. So like 10 squared is going to be 1 and 2 zeros because the exponent is 2. All right. And obviously this is 100. So let's go ahead and write that in. 100. And then we have, if I was going to start at the front, I have 10 squared over 1, which means 10 times 10, because squared, it means there are going to be 2 10s, so 2 10s over 1. And if I write it as multiple fractions, I have 10 over 1 times 10 over 1. 10 times 10 is 100 over 1, which is the same thing as 100. Okay, 10 to the first power over here, notice there is a 1 and then 1 0 because it's first power. Expanded is just 10 because there's only 1 10 over 1, which is going to be the exact same thing over here, which is also going to be the exact same thing over here because you can't multiply that out at all. All right, remember 10 to the 0, any number to the 0 power is 1. So 10 to the 0 over 1 is 1 over 1, okay, which is the same thing as 1 over 1, which is 1 over 1, which is 1. All right. Okay, so again, really quick, let's kind of recap. When your exponents are positive and you're doing a power of 10, remember positive exponents always mean big numbers. Same thing with scientific notation. Positive exponent, big number. Okay, remember if it's positive, the exponent's going to tell you how many zeros there are. Okay, so now let's try some negative exponents. So the first thing here, since it's a negative exponent, remember it doesn't make your answer negative. Negative exponents don't make your answer negative. It makes it a fraction. So what we have is 1 over 10 to the first power, okay, which is 1 over 10, because 10 to the first power is just 1 over 10, which again is just 1 over 10. Okay, and there's nothing we can do to simplify it. But over here, when you write it as a decimal, the first power, okay, remember decimals, negative exponents mean small numbers. The first power means there's only, I would say, one number. Since it's first power, there should be one number after the decimal point. So I always do decimal point, and then since it's one number, I just do the 1. Okay, and the way we write this is 1/10. All right. 10 to the negative 2 power. Okay, again, I write it as a fraction, and my exponent becomes positive, so that's 1 over 10 squared. If I expand it, it's 1 over 10 times 10, because again, 10 squared means 10 times 10. Okay, if I were to write this individually, that's 1 over 10 times 1 over 10, because there are 2 of them. Okay, and that, which is 1 over 10 times 10 is 100. Okay, and since to the second power I do decimal, and then there's 2 numbers behind the decimal point, I always fill in with zeros, and my last number is going to be a 1. All right. Okay, so 10 cubed. Let's do this one without doing all of this stuff. Again, since it's third power, negative, I put a decimal point, and I know there are going to be 3 numbers here, so I always fill the last in with a 1, and then I have 2 zeros. Okay, which is, if I start over here again, to make it positive, I do 1 over 10 cubed, which is the same thing as saying 1 over 10 times 10 times 10, which is the same thing as saying 1/10 times 1/10 times 1/10. Okay, and if we multiply this out, we have 1 times 1 times 1 in the numerator, and that's 1. 10 times 10 times 10, and the denominator is 1,000. Okay, and again, we say this 1,000th. Remember, TH on the end for decimals. Okay, also remember your decimal points behind your decimals is going to be tenths, hundredths, thousandths, 10,000ths. Okay, in front, ones, tens, hundreds, thousands. All right. Okay, so this chart, guys, don't remember, the most important columns that you're going to want to remember is going to be this one. All right. You'll see a lot of like this one, the expanded form. You'll obviously also see a lot of this form, which is writing it out as a decimal number. So these 3 are going to be very, very important. All right, let's keep going. Oops. Okay, next slide is, uh-oh, what happened? Okay, so moving along, we're going to do some practice problems. So what I would like you guys to do is take a second and complete these questions. Complete questions 1, 2, and 3. So if you want to pause the video real quick and let everyone have a second to work on the problems, let's just go ahead and pause it. And remember, guys, also this is a no calculator section. Okay. Hopefully all of you have had a chance to work all 3 of these questions. Okay, so let's go ahead and look at question number 1. The first question says, which fraction and decimal are equivalent to 10 to the negative second power? Okay, the first thing you should remember about 10 to the negative second power, it means you're going to have a fraction, all right? It also means you're going to have a decimal number because we have a negative exponent. The things it does not mean that your answer will be negative, and it also does not mean there's going to be a 2 in here. So what I always do is I automatically cross that off because this one has a negative and a 2, so there are a bunch of reasons. Okay, this one has a negative answer, okay, so we're going to cross that out because, again, a negative exponent does not give you a negative answer. All right. B, we're going to go ahead and cross out because over here it has a negative answer plus it has a 2, and you guys know, looking at the chart, there's going to be no 2's in here. All right, okay, so that means D is your answer. Let's talk about why it is. Remember, the first thing you do when you have a negative exponent is you use the reciprocal, or you flip it. So instead of 10 to the negative second power, you have 1 over 10, and the second becomes positive. All right, and you also remember when you have a negative exponent, what I said you're going to do is you're going to make a decimal point, And then you, since it's second power, you know that there's going to be two numbers behind your decimal point. I always put a 1 at the end and fill the other in with 0. And that's exactly what we have here, so your answer is D. All right, number 2. This is going to be like a technology enhanced question on your SOL. All right, they're going to have this question, and you're going to have to pick the fraction that goes with it and then the decimal that goes with it. All right, so again, we have a negative exponent, and again, that means that does not make our answer negative. So what I'm going to do is cross out these two. All right, it also does not mean that there's going to be 3 in your answer. You're still only going to have 1s and 0s. So over here, I'm going to cross out these two. I guess also we can cross out this negative because we know it's not going to make your answer negative. All right, so let's figure this out. 10 to the negative third power is going to be, so I'm going to first flip it to make my exponent positive. So now I have a positive exponent. And then what that means is 10 to the third power is 10 times 10 times 10, which is 1,000. Okay, which also means, remember, when your exponent's positive, that just means how many zeros you're going to have. So I have 3 zeros because I have 3 exponent. So on a TEI question, I would select this one to go in as my fraction form. Decimal form, we already have the answer, but again, if you want to remember how we do this, since my exponent is negative, I make a decimal point, and since it's a 3, I'm going to make 3 blanks because I know that means 3 numbers. Fill the last in with a 1, and then I put in zeros. All right, so this is going to be your answer. But on a question like this, if you remember, negative exponent does not make your answer negative. You guys can cross a bunch of these out. And also, a negative 3 does not mean that there's going to be a 3 in your answer. Okay, last one on this page is number 3. It says select all that are equivalent to 10 to the negative fourth power. So again, that means 1 over 10 times 10 times 10 times 10, okay, which is the same thing as 10 with 4 zeros. So I have 1, 2, 3, 4 zeros here, so that's going to be one of them. Okay, this we're not going to choose because they're negative. This I'm not going to choose because it's negative. All right, this I can't choose because this is going to not be a fraction answer. It's just going to be plain old 1,000, so we're not going to have this. All right, and since this is negative fourth power, again, I can do a decimal point, 1, 2, 3, 4 spots. So I have a 1, and then I fill in with 3 zeros. All right, so this one works. And this one's going to work also because since it's to the fourth power, that means I have 1/10 over 1/10, 1/10, 1/10. I have 4 of them. All right, so this one works as well. Okay, let's keep on going. Okay, this one, for this, oh sorry, we need to answer this question over here. It says, at the bottom of this page, what's the most important thing to remember about powers of 10? Okay, a couple of things to remember. Remember, does not mean no negative answers. It does not make your answer negative. Okay, it also is always going to be, okay, powers of 10 answers are always going to be 1s and 0s. Okay, just because you have a second power does not make put a 2 in your answer. Okay, another thing to remember is positive power or positive exponent means big number. All right, and then the exponent, when it's positive, so this is all positive exponents, equals the number of zeros. All right, so in other words, if I have 10 third, I'm going to have a big number, and since it's positive, I'm going to put a 1 and 3 zeros. Okay? All right, negative power or a negative exponent means small number or decimal. All right? Okay, and the exponent tells you how many spaces you have behind your decimal point. Okay, and then you always start here with 1 and fill in. Okay? Okay, so moving along. We're going to talk about, what is this called? Scientific notation. Right? Remember, scientific notation is when they take something really big and make it smaller, or they take something super small. Okay, and then you don't have as many decimals and zeros to deal with. Okay, a couple of things about scientific notation. Remember, this is what scientific notation looks like. Okay, you're going to have a number up front between 1, it has to be greater than or equal to 1, but less than 10. In other words, on the number up front, you have your decimal point and you have one number in front of it. Okay, when you have a positive exponent, when the 10 has a positive exponent, the standard notation will be a big number. Remember, scientific notation is when you have it times 10 to a power. Standard notation is normal. To change the scientific notation into standard notation, count the decimal places to the right, because remember we're making the number bigger, so we go to the right. Alright, circle the number that equals 4.5 times 10 to the third. Okay, remember this exponent tells you how many spaces you're moving your decimal. So if I have 4.5, this tells me, since it's positive, I'm going 3 to the right, so I go 1, 2, 3. Okay, remember, you're counting the 3 movements. Since that's 3, I should see 1, 2, 3 humps, and then I fill in with zeros, and I get 4,500. Okay, so this is my answer. All right, let's look at the negative exponents. Okay, when you have a negative exponent, the standard notation will be a decimal number or a small number. Okay, to change the scientific notation to standard, you're going to count the decimal places to the left of the decimal. All right, so again, we have 4.5 is the number up front, but this time I'm going to the negative 4th power. So again, I'm going to move my decimal point 4 spaces to the left. So I go 1, 2, 3, 4, and on that last one, I'm going to put a decimal point. Okay, so again, I went 1, 2, 3, 4, so then I can put in 3 zeros. All right, so my answer has 3 zeros and 4, 5. Okay, now what happens if you have standard notation, which is what this is called? Okay, when a whole number is changed into scientific notation, the exponent is positive. Okay, and in this one, the decimal is going to go between the 4 and the 7, because remember, there can only be one number in front of the decimal point. So there's my one number in front of the decimal point. Okay, and now they want you to change this into scientific notation. So obviously my new decimal, I said, is going to be between the 4 and the 7, because again, one number in front. And then I'm just going to count how many spaces I have to move to get to the end. So I go 1 space, 2 spaces, 3 spaces, 4 spaces, 5 spaces. And since this is a big number and I went to the right, my exponent is positive. So I'm going to have 4.7 times 10 to the 5th power, because we said I had to go 5 spaces to the right. Okay, for negative, when a decimal number is changed into scientific notation, the exponent is negative. Okay, and again, the decimal is going to go between the 4 and the 7. Okay, because here is my new decimal point, because only one non-zero number can be in front. All right, and again, I'm going to count the number of spaces it takes me to get from decimal point to decimal point. So I'll start either way, 1, 2, 3. So that means I had to move 3 spaces, and since this is a decimal number, I'm going to have 4.7 times 10 to the negative 3rd. Okay, because it is a small number, so my exponent will be negative. All right, make sure you do some practice problems with this. Okay, so next it says, when you order numbers written in scientific notation. Okay, whenever you have numbers in scientific notation, and all of these are written in correct scientific notation, the first thing you're going to do is you're going to look at the exponents. So the first order you're going to use is the order of the exponents. Okay, so you're just looking at -3, -2, -2. All right. Okay, so you obviously, depending on if you want the smallest or the biggest, you're going to look at your exponents and do them that way. Okay, but if you guys notice here, I have 2 -2s. All right, so when you have the exponents, if you have 2 exponents that are the same, okay, you have to order the number. So the number that's in front. So that's what you're going to look at. So here I have -2, -2, but the number up front I have is 2.1 and 6.9. Okay, obviously 6.9 is bigger, so if I was going least to greatest, this one would come before this one. Okay, And this one would be first because my exponent, when I did my first step and I looked just at my exponents, -3 is the smallest exponent, so that would be first. Okay, and since these exponents are the same, I would go and look at the numbers in the front, and 2.1 is smaller than 6.9, so that would be second and third. All right, so let's do this example really quickly together. Okay, so I've got these 3 scientific notation questions. Actually, they just told us to do it. So first thing I do, -3, -2, -1. Okay, since -3 is smaller than -2 and -1, obviously 3.5 times 10 to the -3rd is going to be the smallest. Okay, and since I have -2 and -2, they're the same. I look at these numbers up front. 2.1 is smaller than 6.9, so the next smallest is 2.1 times 10 to the -2nd, which leaves 6.9 times 10 to the -2nd last. So that's ordering them from least to greatest. On your SOL test, please circle or highlight what order you're going in. Okay, they also call least to greatest, they call it ascending order, because when you ascend something, you go smaller and you go bigger, 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 bigger. And so that's what ascending order is. Descending means you get smaller, 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 okay, which would be greatest to least. All right, so on the next page, what I would like you guys to do is these problems, 1, 2, and 3, go ahead and take a couple of minutes, pause the video please, and take a couple of minutes and try these problems on your own, okay? Remember, again, no calculator, please. So Miss Logan, if you can just pause the video for a couple of minutes and give everyone a chance to work. Okay, I'm assuming everyone is done or has had a chance to work some of these. Okay, the first one says, what is this number written in scientific notation? First thing is, I know I'm going to put my new decimal point right here between the 5 and the 2, because again, there's only one non-zero number in front of my decimal point. All right, and because this is a small number, I know that my exponent has to be negative. So I'm going to cross out A because it has a positive exponent, and I'm going to cross out B because that also has a positive exponent, and I know my exponent has to be negative. All right, so then I'm going to count how many spaces, because I have a choice between -4 and -5. So I'm going to count how many spaces I have from decimal point to decimal point. So I'm going to count them, 1, 2, 3, 4, 5. So I know my exponent will be a -5, and it's 5.2 times 10 to the -5th power. All right, number 2 says, which two statements show a number and its equivalent written in scientific notation? Again, this is going to be a technology enhanced question, so you have to get both of them right in order to get this one right. Okay, so let's check out this first one. All right, my decimal point's in the right place, so we'll put it here, and it says +7th power, which means I'm going to go to the right because my number has to get bigger, and I should be going 7 spaces. So 1, 2, 3, 4, 5, 6, 7. All right, that works. So this is one of the correct ones. Okay, I'm going to look at this next one and already know that this is not right because my exponent's negative, which means that I should be moving my decimal to the left to make it smaller. It looks like this person moved it to the right. So this one cannot be it. All right, the next one says 10 to the +3rd power. All right, so then I'm going to start here. Oh, I know why. This one can't be right because look at the number up front. Remember, your decimal point can only have one number in front, so your decimal point is in the wrong place. So that is not proper scientific notation. All right. This one, again, I know is not right because, again, I have a positive exponent, but I have a very small number. So this one should have a negative exponent, so I'm going to cross that one out. All right, so let's look at our last one. We have negative exponent, very small number. So far, it checks out. All right, so then I'll put my decimal point right here because I'm going to put it between these two because there's only one non-zero number in front. All right, so I should be able to move 6 spaces from point to point. So 1, 2, 3, 4, 5, and 6. All right, so there's my other one. Okay, remember in scientific notation, the big thing is count your place values or how many times you move that decimal point, you are not counting zeros or anything else like that. Okay, so please be very, very careful. Okay, guys, this is the last section. Okay, this is going to be 7.1c, where we're ordering our rational numbers. Okay, and again, this is another no calculator section. All right, and these are some of the fractions we had you memorize as decimals. 1/2 was easy, is 0.5 because that's half. 1/3, don't forget, it's 0.3 repeating. 1/4 is 0.25 because a quarter is a quarter, like 25 cents. Okay, 1/5 is 0.2 because the way we do it is we say 1/5 is the same thing as, if I was going to do it as tenths, 2/10. Okay, so it's 2/10. 1/6 is 0.1 with just a 6 repeating. 1/7, ooh, this is an ugly one, 0.1428, and that repeats, so it's 1428, 1428, 1428. Okay, 1/8 is 0.125. 1/9, the beautiful thing about your ninths family is you just take your numerator and you repeat it. So 1/9 is 0.11111, 2/9 would be 0.22222, etc. Okay, 1/10 is just 0.1, 1/11 is 0.09 repeating, 1/12 is 0.083 repeating. These aren't as common, but the ones up front definitely are. Okay, it says, first thing, use the unit fractions from above to answer these questions. What's a decimal for 3/5? Okay, very quickly, guys, 3/5 is the same thing as saying if I want to make it into a tenth, because remember the first easiest way to change a fraction to a decimal is to see if you can make a denominator like a 10, 100, 1,000. We know this is an easy 10, so I multiply by 2. I do 5 times 2 and I get 10, so that means I have to do 3 times 2 and I get 6. Okay, this is 6/10, so 6/10 is 0.6. Okay, convert 5/8 to a decimal. If you look at your family up here, 1/8 is 0.125. If I've got 5 of them, you could just multiply this by 5, or you can do 5 divided by 8. All right, and if you do that, you get 0.625. All right. Next one, what is the percent for 2/3? If 1/3 is 0.333, 2/3 is doubling it. So what I say is it's 0.6 repeating. Okay, 3/4 to a percent. Oh, whoops, this says what is the percent. So since this is 0.6666666, what I say is I round it to 67% because I know the next number is going to be a 6. All right, 3/4 to a percent. This is like saying you've got 3/4. Okay, because it's 3/4. 3/4 is 75 cents. Okay, but since they want you to make it a percent, 2 spaces to the right, which means now I have 75%. Okay, what is the decimal equivalent of 5/6? For this one, honestly, I would just divide it out. So I have 5 divided by 6. Okay, remember you put a decimal point and a 0. So 6 goes into 58 times, and you get 48. And then you have 2, bring down another 0. 6 goes into 20 3 times. Okay, and then you get 18, and you guys see it's going to be a 2 again, so it's going to go 20, 20, 20. So my 3's are going to repeat. So I have 0.8, and then 3 with just a 3 repeating. 5/9 to a percent. This is easy. Remember, if you have a ninth as your denominator, you just take your numerator and you repeat it. Okay, and that's it. All right, some steps. If you're going to order, convert each number into, usually we do a percent, okay, or a decimal because they're the easiest to compare. All right, so decimal. Okay, if you're doing decimals, line up the decimals to compare place value, or think about them like they are whole numbers. All right, write the original numbers in order. So, okay, first thing, greatest to least. So the biggest goes first, smallest goes last. All right, so we're going to convert all these. 8/9, remember this is a ninth family, so it's going to be 0.8, 8, 8, 8, etc. Okay, 67%, I'm just going to take my decimal point and move it 2 spaces to the left. So I get 0.67, 1.4 stays as is. 5/4 is the same thing as saying 1 and 1/4. which is 1 1/4 is 25, so 1.25. So I'm going biggest to smallest. So my biggest number is 1.4, so I have 1.4. My next biggest number is this 1.25, so that's 5/4, so that's going to go next. All right. My next biggest number is 0.88888. That's bigger than 0.67, so 8/9 comes next. So last but not least is 67%. Okay, next one. It says place these numbers on a number line. All right, so first of all, let's do negative 0.5 because that's easiest. So if this is 0, this is negative 1/2. Okay, so this is going to be negative 0.5. All right, 43% is just 0.43. So again, this is 1/2. 0.43 is a little bit smaller than 1/2, so we'll make this 43%. Okay, negative 7/3. Okay, if I make this a mixed number, 3 goes into 7 twice with 1 left over. So that's basically saying negative 2 1/3. So here's negative 2. 1/3 is going to be smaller than 1/2. So we'll put it right here, and we'll call that negative 7/3. 1 1/8 is 1, and remember an eighth is 0.125. So it's going to be a teeny bit bigger than 1/8. And so that's my 1 1/8. Okay? So if I was going to look at this and say in ascending order, meaning it's going smallest to biggest, okay, here's our ascending order. 2 1/3, I'm sorry, not 2 1/3, negative 7/3, negative 0.5, 43%, and then 1 1/8. And that's your ascending order, because remember, ascending means you're going from small to bigger. All right, so okay, the last thing you're going to do on this page is you are going to complete the last few questions. Okay, again, there are 4 questions. I want you to pause the video, and I want everyone to take a couple of minutes and work on the video, or I'm sorry, on the questions, and then we will go over them. So again, if you can pause the video, that would be great. Okay. Now that we are back, hopefully you guys are all done. All right, so number 1, it says which of these is a true statement? So again, you're just comparing rational numbers. All right, if you look at these two, you have 0.25 and you have 20%, remember, just move the decimal point 2 spaces to the left, so 1, 2. Okay, so what's bigger, 25 cents or 20 cents? Okay, 25 cents is bigger, so this one is not true. 2 1/8. Okay, let's look and see what this is going to be as a mixed number. 8 goes into 11 once, and then you have 3 left over 8s. So again, these are not equal, so we'll cross that out. Negative 3/4 is negative 0.75, and negative 1/2, negative 0.5. Okay, they are saying this one is less than this one. Okay, and the statement is actually true. Because remember, when you're negative, most people look at 0.75 and say that's bigger than 1/2. But remember, since they're negative, this one's 0.75 is further than the 0. So this one is true. All right, and this one is going to be 1.3 is less than 5/6. Obviously, that's not true because 1.3 is going to be bigger than this fraction. All right, number 2, you're looking at what number could go in the middle. In other words, the number you put in the middle has to be bigger than 2/11, but smaller than 1.42. All right, so what you're going to do, 2/11 is, if we do the math, we'll do 11 goes into 2. Okay, it goes into 20 once, so I have 11. And then I have 9, bring down a 0. Then I have 8, okay, which is going to be 88. Which is a 2 again, 1. All right, so 2/11 is 0.18 repeating. 1 2/3 is 1 point, and if you remember, 1/3 is 0.333, so 2/3 is 0.6666. Okay, 1.6 or 1.66 is bigger than this, so this one does not work. All right, 0.15 is smaller than 0.18, so this one's not going to work because it has to be bigger. Okay, this one is 0.22 because again I'm going to change it into a decimal. All right, so this is 0.22. And is 0.22 bigger than 0.18? Yes, and it is smaller than 1.42. So this is your correct answer. All right, number 3, it says arrange the 4 numbers from least to greatest. Okay, first thing, let's do this. Negative 11 6 is the same thing as saying 1 and 5 6. So this is basically negative 1 and 5 6. So I have negative here, 1 point, and we said 5 6 is 8 3 with the 3 repeating. All right, so 6.7%. Move your decimal 2 spaces to the left. All right, this one is 0.067. This one is obviously just negative 6/7, or I'm sorry, negative 0.67. For our 6/7, basically we can divide it and see how it goes. So 7 goes into 60 8 times, so that's 56. Okay. So then I have 4 and a 0, so 7 goes into 40 5 times. Okay, and it's just going to go 5 5 5 5 5, or 5. No, I lied. So, but this is going to be about 0.85. Okay, and we want to go from least to greatest. So right now, obviously, our 2 negative numbers are the smaller ones. Okay, negative 1.83 is further from 0 than this. So this negative 1.83 is the smallest. So we're going to put it back in its original format. So we have negative 11 6. Then my next number is negative 0.67. Okay. And then I've got 0.067 and 0.85. All right, so 0.067 is smaller. So I have 6.7%. And my last one is going to be the 6/7. Okay, and that's smallest to greatest. All right, last one. Which number is greater than 1 3/10? If I want to write that as a decimal, it's just 1.3. Okay, we want something greater. This is not greater than 1.3. Okay, and this is 1.2. Okay, which is also not greater, so we'll knock that out. This one's negative, so obviously that's not greater. So your answer is going to be this. Okay, but if you want some assurance, if you go 3 goes into 7 twice with 1 left over, so this is the same thing as 2 1/3. So obviously 2 1/3 is bigger than 1 3/10. Okay guys, so that's it for your notes. What your homework is you are going to, after this 7.1c, okay, you're going to see a page that says 7.1d, perfect squares, skip it. Then you're going to see 7.1e, absolute value, skip it. Okay, and then you're going to hit the first page, and in the bottom right hand corner it says HCPS, but in the top left hand corner it says 7.1a. Okay, and the first question on the page says, what is 10 to the 5th equal to? That's your first page of homework. The next page is 7.1b. You're going to do that next. Last page is 7.1c, and that's going to be your last page of homework. If you can finish it in class, great. Otherwise, it is homework. All right? Okay. Talk to you guys later.